All right, so we're looking at chapter 23, which is about product design. And if we were in our AEC, we'd be able to actually see like CAM software being used and CAD software being used, and then how that relates to manufacturing. But generally what we're looking at is that there are multiple support systems that are used in manufacturing: quality control, material handling, automation, um, but then there are also the product design system itself can be facilitated through computer assistance. So CAD drawings like we use with AutoCAD, or CAM drawings like with SolidWorks and MasterCam and other support systems, we're able to design our product and then very quickly convert that into manufacturing operations. So the design process for any product starts with the recognition of a need and a problem that you're trying to solve. So we design things out of necessity, and then we continue to create a product that will meet those needs. And that process is cyclical of looking at how to optimize that process, looking at how to optimize that product until we get to a point that we can actually manufacture something. CAD is able to come alongside this process and help with the actual modeling, analysis. You can do structural analysis, cost analysis, allowing for design and evaluation. We can do rapid prototyping using 3D printers from CAD drawings and things like that to see if what we've designed is the best fit for the process that we have. And so CAD helps the designer become more productive in that you can use lots of cool features that help you to call back frequently used features of the software or objects that are frequently used. You can modify existing designs, like change the file. So if you have a small product change, you can generate a new product drawing very quickly with just making minor modifications. It helps to improve the quality because you can consider more alternatives more quickly. It's better documentation, and you're able to hold on to that knowledge, that institutional knowledge. Even if the designer leaves, someone else who also knows CAD can access that drawing and know exactly what that person was doing. And then it helps with the standardization because you're able to see what you've done previously and continue with that process. So basic drawing in CAD, you see here like a wire frame model, like making a pole barn or something, very simple shapes. Obviously they get much more complicated than that, but we can do both 2D and 3D rendering in CAD to build our parts and then design them from there. For computer-aided manufacturing, most of the time you're thinking about that as like a CNC, computer numerical control, where we're actually using a CNC mill or lathe to automatically create the part off of that CAD drawing. But computer-aided manufacturing actually goes into the planning as well, even though we don't often think of it in those terms. And so it could be with cost estimation, inventory planning, line balancing. All of those are applications of computer-aided manufacturing. It's just not what we think of when we think of CNCs, which you see are also on the list. And so computer-aided manufacturing actually encompasses not just the CNC and the CAD, but it also encompasses these other programs that we might use, like an Oracle system or an SAP system or some other MRP that is able to help us in these other manufacturing planning aspects. And we'll talk about more of that next week when we go into MRP systems in more detail. So whether it's the process monitoring, quality control, activities on the shop floor, the inventory, or even helping to facilitate just-in-time systems and move product through and basically create electronic Kanban systems, which we'll talk about in 2 weeks, whatever the application may be, if it's a computer-aided system, a piece of software that is helping us do these tasks, it falls under CAM. And so then computer integrated manufacturing is the combination of all of these computer aided functions from the time that the order is received all the way through the time that the product is shipped. And so when we think about supply chain management, like my field of study, we're really looking at an enterprise level, all the way from the business functions of order entry and billing and accounts receivable to looking at what product the customer has ordered, having the product designed and drafted, having it manufactured to the right quantity, to the right quality standards, using our process controls, all the way through the shipment to the final user. And so all of those actually fall under the scope of computer integrated manufacturing, and then specifically on the shop floor, that CAD CAM scope. And so next time, we're going to talk a little bit about process planning. That's chapter 24. Well, there'll be a brief discussion of the philosophy of process planning. And then in chapter 25, we're going to dig deep into our ERP systems, our enterprise resource planning, and our MRP systems, our manufacturing resource planning, of how do we get the right product to the right place at the right time for manufacturing, so we never have unexpected downtime on the line. It's a critical function in manufacturing, and it cannot be overemphasized. So that is it for chapter 23. And chapter 24 is also part of this week, so make sure you watch that video as well.